Hello and welcome to MyScience Tutorials. In today's video, we are going to be looking at vertical motion under gravity. Before we begin, if you are new to MyScience Tutorials, kindly consider subscribing and pressing that notification button so that you don't miss any of our latest tutorials on biology, chemistry, mathematics, and physics. Alright, in today's video, we will be looking at the motions of a body thrown either vertically upwards or falling freely downwards. That is, we are ignoring air resistance under this motion. Alright, so if we have a body thrown upward, okay, gravity acts downwards on this body. Now, this body is now working against gravity. Okay, so it means this body will have to use a certain amount of force to be able to propel itself upwards against gravity. Now, this body being thrown has a velocity with which it was thrown. Now, it reaches a certain height before it falls down, and then it takes a specific amount of time for this body to reach this height before it begins to fall. So if we take all these parameters into consideration, then we will come up with what relationship between the height, the velocity, the time, the gravity, which are what we call the equations of motion under gravity, which are very, very important when we want to solve what problems under what motion of gravity. Okay, so for a body being thrown upwards, let's look at the equations that we have. So for vertically upward motion, that is, we are working against gravity, so we give gravity what negative g. We give it negative because what we are working against gravity, not for gravity. So the first equation that we use for vertically upward motions is what v is equal to what u minus gt. Then the second one is what v squared is equal to what u squared minus what 2gh. The third one we use is what h is equal to what ut minus half gt squared. Now, the v is the final velocity of the body, u is the initial velocity, g is the gravity, and then t is the time. Then h is the height at which the body has reached. Alright, now if we throw a body upwards, the body only has what an initial velocity. So it means what whenever we throw a body upwards, okay, final velocity, which is what v, is always equal to 0. For a body being thrown what vertically upward, final velocity is always what equal to 0. Okay, let's now see vertically downward motion. Okay, so if the body has gone up and it's now coming down, let's look at the equations that we have for this. So for this one, because the body is coming downwards, it is working for gravity or with gravity. So gravity here is what positive g. So it means we will still maintain all this equation, but we just change the sign over here to plus, and that will give us what the formula for motions of a body moving downward. So let's have the first one is what v is equal to what u plus gt. Then the second one is what v squared is equal to what u squared plus what 2gh. The third one is what h is equal to what ut plus half gt squared. Now, for a body acting downwards or coming downwards, okay, initial velocity of the body is what always equal to 0 meters per second. That is because the body has already been thrown upwards and it is now coming down. So it is now coming down with a new velocity, which is what the final velocity and not the initial velocity. So we need to take note of these two things. So for a body going upwards, final velocity is 0. For a body coming downwards, initial velocity is what is 0. Okay, looking at these formulas that we've written so far, we can make some deductions from this formula. Let's have a look at the first deduction that we can make. Okay, so we want to find what the time taken to reach the maximum height. Time taken to reach what? Maximum height, H max. All right, so we want to use for a body to reach the maximum height. So let me draw the diagram. So we have a body being thrown upwards, and it goes and it comes down. Okay, so this is what we are calling our what? Our maximum height. Okay, so for a body to reach this maximum height, for us to calculate the time, we use the formula what? V is equal to minus what? GT. Now, remember I made mention of the fact that if a body is being thrown upwards, the final velocity is 0. So it means here, over here, V is equal to 0. If this holds true, then it means what? We can rewrite this at what? As what? 0 is equal to what? U minus GT. Making GT the subject, we have GT is equal to U. That is, we brought this to the other side of the equal to sign. So making time over here the subject, we can have time is equal to what? Initial velocity divided by gravity. So this is the time taken for the body to reach the maximum height. Let's have a look at another one. So let's now find how we can get the maximum height reached by the body. So for the maximum height reached by the body, we use the formula V squared is equal to what? U squared minus what? 2gh. Now we know over here velocity, final velocity is still equal to 0. So we say what? 0 is equal to what? U squared minus what? 2gh. So bringing 2gh across the equal to sign, we have this is equal to what? U squared. So we divide both sides by 2g. So we have our maximum height, H max, to be equal to what? Initial velocity squared divided by what? Twice the gravity. Alright. Now, there's another thing that we can find, which is the third one, that is time for flight. Now, the time for flight simply means what? The time it takes the body to reach the maximum height and come down, which is technically what? It's just what? Twice the time it takes to reach this height, because it will travel the same distance upward and come down with the same distance. That is, if we are ignoring air resistance. So it means what? The time for flight is what? Twice the time taken to reach the height over here. Let me do that properly. So it means what? Our time for flight will be what? Twice this time over here, which means we will have what? 2u over what? J. So our time for flight, okay, for this particular one is just what? Time for flight is just twice the time taken to reach the maximum height, which is what? U over G, and this is equal to what? 2u over G. Alright, let's have a look at some special cases in this example. Now, assuming a particle is projected vertically upward at a point above the ground, then the maximum height reached can be calculated differently. So what do I mean by this? Assuming we have, let's say, something, or you are on top of a cliff or a tower or something, and then you project a body upward and it goes and comes down. Now remember the first one that we did, we assume you are on the ground and then you are projecting the body, okay? But now you are on what? A cliff that has what? A certain distance, okay? So let's make the distance what? Y. A certain distance y before you projected the body to go up and comes down. So it means what? The maximum height that you will reach, okay, over here, the maximum height, okay, will be what? Y plus the height that you calculate, assuming you assume this is what? Your ground or your floor. which is what your h max, which is what we found earlier. Okay, so in earlier we said what the maximum height you reach is what u squared divided by what 2g. So all we need to do is just what add y, this distance of the cliff to it, so that we can get what the maximum height reached. Okay, so now assuming we are asked to find what the total distance covered, okay, this is what maximum height, that is if you're on a cliff, you just add what the height of the cliff to what the maximum height that you calculate for the projection. So it's still y plus what u squared over what 2g. Now assuming we are being asked to find what the total distance covered. Now the total distance covered include what from here up to here, and then the y, which is the distance of the cliff over here. So which technically means what we need to what multiply our height, maximum height reached, by 2. What do I mean by this? So if this is our height, okay, if this is our height, then coming down this is another height, let's say h1. Okay, so for us to get, and then this is y, so for us to get the total distance covered, we need to add this height from here up to here, then we add this height as well, then we add the height of the cliff, which is what total distance. Our total distance is equal to what our h, which is what the maximum height, okay, h plus the h when it's coming down, okay, h again, then plus what y, which means what our h, we are calling it is maximum height, and then the distance is just the same, so this is what twice the maximum height, h max plus y, to give us what our answer. But then we are saying what our maximum height is what u squared divided by 2g. So if we substitute that over here, we are going to get 2 into bracket u squared over what 2g plus y. So this means this will cancel out, and then the total distance for special cases on a cliff or on a tower or anything will be what u squared over gravity plus the height of the cliff y. With this basic introduction, let's have a look at some practical problems to further enhance our understanding about the concept. Example number 1. A stone is dropped down a wall. If it takes 5 seconds to reach the surface of the water, how deep is the wall? What is the velocity when it hits the surface of the water? This is a very nice question. So let's go in. So first of all, we want to write our solution here, and then we write down our parameters. So a stone is dropped down a wall. If it takes 5 seconds, so our time given to us is what 5 seconds to reach the surface of the water, how deep is the wall? Now let's consider the first statement over here. A stone is dropped down the wall, so it means what the motion is what vertically downward. So it means what our gravity is what positive. And then when we are talking about what motion coming downwards, we know what we don't have what initial velocity, but we have what final velocity, which means what initial velocity is equal to 0 for vertically what downward motions. Now that we are able to make this deduction, and then we are being given gravity to be what 10 meters per second squared, we can easily go ahead and calculate the height or how deep the wall is. So then we get to use the formula that involves the height, which is h is equal to what ut plus half gt squared. So our h is equal to what our initial velocity is what 0, because it is coming downwards. So we have 0 into bracket the time, which is 5 seconds plus half, gravity is 10, and then our time is also what 5 squared. So our height is, this is 0, this is 5 times 5 squared is 25. So our height, or the height of the wall, is what 125 meters. So this is the height of the wall for this example. Now I. What is the velocity when it hits the surface of the water? That is what the final velocity with which the body is coming downwards. So with that, we simply go ahead and use what V is equal to U plus what GT. As usual, the motion is what a downward motion, so our initial velocity is what 0. So it means our final velocity is simply what the product of gravity and time, which means our velocity is what gravity, which is 10, and then our time, which is what 5. So it means it is coming down with a speed of what 50 meters per second. All right, let's have a look at another example. A rocket is fired vertically upward, the word or the phrase vertically upward, and reaches the height of what 400 meters. I. What is the velocity of the projection of the rocket? I. How long does it take to reach the maximum height, given that gravity is equal to what 10 meters per second squared? So let's dive in. Solution. A rocket is fired what vertically upwards, so it means what our gravity is what negative 10 meters per second squared, because it is what going against gravity. And then we have our height to be equal to what 400 meters. Now, because the motion is what a vertically upward motion, we know our body will have initial velocity but not final velocity, so our V is equal to what 0 meters per second. Beautiful. So with this, we can now go ahead and calculate what I. What is the velocity of the projection of the body? So we simply go ahead and use what V squared is equal to what U squared minus what 2gh, because we have height. Now we know final velocity is 0, so we just have here 0 squared is equal to what U squared minus 2. Our gravity is what 10. The gravity being 10 is the negative over here. The negative over here is as a result of the negative that we placed over here. So you don't need to substitute negative 10 in place of gravity over here. If you want to use the negative 10, then this has to be plus. But because the negative, the gravity is negative, that is why this negative is here already. So you don't need to use negative 10. I just want to bring your attention to that. So our height is what 400. So we bring this whole side to the other side of the equal to sign. So we have what 20 times 400 is equal to what U squared. So if we multiply everything over here, we are going to get 8,000 is equal to what U squared. So U is now equal to what the root of what 8,000, and then our U, which is what the initial velocity of the rocket being fired vertically upwards, is what 89.44 meters per second. Beautiful. Now let's look at the second aspect. How long does it take to reach the maximum height, which means what the time taken to reach the maximum height? All right, let's go and look at that. So how long does it take to reach the maximum height? So we have what V is equal to what U minus what GT. So it means what our GT is equal to U, which we have over here. All right, let's go ahead and make what the T the subject. So we divide both sides by gravity, and then we get what our time to be what U over G, as I showed earlier on. All right, so it means our time taken to reach the maximum height is now what 89.44 divided by 10. Okay, so 89.44 divided by 10, that is the gravity, will give us what a time of what 8.94 seconds. So it means what the time it took the rocket to reach the maximum height is what 8.94 seconds. All right, let's have a look at one final example. And the question reads: a stone is thrown vertically upwards from the top of a tower. This is one of the special cases that I described earlier on. This is one of the problem. So I read the question again. A stone is thrown vertically upwards from the top of a tower 50 meters high with an initial velocity of what? 20 meters per second. Calculate I, the maximum height reached by the stone. I, time taken to reach the maximum height. And then I, the total distance covered. Beautiful. So let's go ahead and write our solution down. Now let's write our parameters before we worry about any diagram and anything. So a stone is thrown vertically upward. So we are dealing with what? An upward motion, and it means what? Our gravity is what? Negative 10 meters per second squared. All right. Beautiful. This is what? A vertically upward motion. So it means what? Our initial velocity is known, but then our final velocity is what? Equal to 0. That is another deduction that we can make from there. Okay. So we have the height of the tower to be what? 50 meters. All right. And then our initial velocity is given to us as what? 20 meters per second. So we have to calculate the maximum height the stone reaches. Okay, so let's draw the diagram. So we have a tower. This is our tower. Beautiful. Then we throw a stone vertically upwards, and it goes and it comes down. So the height of the tower is what? 50 meters. Yes. And then this is our what? H marks our maximum height. Then our initial velocity for this body is what? 20 meters per second. So we want to find what? The maximum height reached. So from v squared is equal to what? U squared minus 2gh, and the minus is as a result of what? The motion being what? A vertically upward motion. All right. So we have our final velocity to be equal to what? 0. So it means 2gh is equal to what? U squared. So our maximum height is what? H is equal to what? U squared divided by what? 2g, which means this is equal to what? The initial velocity squared, 20 squared, divided by 2 into bracket what? Gravity, which is 10. Okay, so our maximum height over here, this is equal to what? 20 meters. All right. Now, time taken to reach the maximum height. The time taken to reach the maximum height is what? U over g, as I showed earlier. So it means what? Our time is equal to what? 20 divided by gravity, which is 10. So our time is what? 2 seconds. I. The total distance covered. Beautiful. Like I said, the total distance is what? The height of the tower, which is what? The 50, plus what? Twice the h max, that is what? Twice the maximum height, because this is 1, this is 2, and then the from here downwards is just the height of the tower. All right, so this means we have 50 plus 2 into bracket our maximum height. Thank God we've calculated it, and it is 20. So we have here 20. So we have what? 50 plus 40, and then this will give us what? 90 meters. So the total distance covered in this particular example by the stone is what? 90 meters. So thank you so much for watching. If you find the tutorial helpful, kindly consider subscribing and then pressing that notification button. So until I see you next time, bye bye and stay safe. Thanks.